Beneath the Geneva gloom, far below the world's surface, lies a stunning triumph of human ingenuity, and an inevitable harbinger of devastation. The Large Hadron Collider, or LHC, is a marvel of intelligent analysis, allowing researchers to investigate the subatomic realm and triggering the discovery of the elusive Higgs boson, often dubbed the God particle. This innovation has captivated the scientific world. Yet, as renowned physicist Brian Cox once ominously declared, a hidden potential has been uncovered at CERN, sparking a wave of curiosity and concern. Could our pursuit of knowledge have led us down a dangerous path? Have we set our course for an uncertain future, possibly one that defies our understanding? Before delving deeper into this startling statement, it's essential to first examine the colossal machine that is the Large Hadron Collider. Managed by CERN, the LHC is an imposing 17-mile ring of superconducting magnets. It is by far the largest and most powerful particle accelerator ever developed. It is the pinnacle of scientific achievement, capable of recreating circumstances that rival the universe's creation itself. This incredible apparatus allows researchers to investigate the fundamental components of the cosmos, but with such power come unanticipated effects, possibly even venturing into the realm of the unknown and terrifying. Founded in 1954, CERN has become one of the world's most prestigious and vital research centers, with 23 countries as members and a vast network of experts. While the LHC is its most high-profile project, it is only one component of a vast array of accelerators and detectors aimed at comprehending the smallest components of the universe. The LHC is a race to uncover the very building blocks of existence. It speeds up protons to nearly the speed of light, sending them on a collision course that simulates the energy and conditions of the universe at its inception, temperatures millions of times hotter than the sun's core. An intricate web of magnets guides these particles along their path, while highly sophisticated cooling systems maintain a supercold environment, far colder than even outer space. The LHC is equipped with 1,232 dipole magnets that steer the protons and 392 quadrupole magnets that focus the beam. Just before collision, another type of magnet increases the likelihood of interaction. The mission: to collide particles with such precision that it is comparable to hitting two needles placed 6 meters apart. The accuracy required for this operation is staggering, and the technology involved is unparalleled. The collider's construction features deep underground, concentric rings that shield it from harmful radiation. To achieve optimal performance, the entire system is cooled to -456 degrees Fahrenheit, colder than the vacuum of space. The underground setup houses 4 distinct particle detectors: Atlas, CMS, ALICE, and LHCb, each with a unique goal in examining different aspects of particle physics. These detectors are equipped with massive sensors that record particle interactions, with experts frequently analyzing the data in search of traces of the Higgs boson. This mysterious particle is considered essential to understanding the very fabric of the universe. Understanding the microcosm helps us decipher the macrocosm, like solving a massive, cryptic jigsaw puzzle. However, with each new piece added, new questions and mysteries emerge. Each discovery leads to another challenge. The LHC is more than just a scientific tool. It is an embodiment of human ambition, progress, and the unwavering determination to comprehend the fundamental forces that shape our universe. But as we venture into the unknown, we must also confront the moral and existential dilemmas that accompany such bold investigation. What are the risks associated with delving into the unknown? Could our quest for understanding unleash forces beyond our control? In recent months, an unsettling revelation has sent shockwaves through the scientific community. Brian Cox, a former researcher at CERN and a prominent figure in the field of particle physics, made a statement that piqued both curiosity and alarm. According to Cox, the goal of the LHC, to recreate a version of the Big Bang in miniature, reproducing the very event that gave birth to our universe, could lead to unforeseen consequences. The collider's impressive ability to probe the Higgs boson and investigate the dark enigma, a substance that makes up a significant portion of the universe, could potentially unlock truths beyond our comprehension. The concept of locating the darkest mysteries of the universe is thrilling, yet fraught with risk. The LHC recreates the extreme conditions present at the inception of the universe: temperatures, pressures, and energies unlike anything we can observe in daily life. It's like we're looking through a window directly into the moment the universe began. But such enormous power comes with huge responsibility. Take, for example, the incident involving a Russian physicist, Anatoly Bugorsky, in 1978. While conducting research at the U-70 synchrotron in the Soviet Union, a tragic accident occurred. A proton beam accidentally penetrated his skull, causing significant damage to brain tissue. Miraculously, he remained conscious and even walked to seek treatment. His experience serves as a stark reminder of the potential dangers associated with particle accelerators. The power harnessed by these machines should never be underestimated. Concerns about the LHC's capacity to create black holes, albeit on a very small scale, have raised alarms in the academic community. Black holes are regions of space with such intense gravity that not even light can escape. Some scientists have expressed concern that the LHC might create a miniature black hole, one that could theoretically consume the Earth from the inside. While researchers at CERN have reassured the public that any black holes created would vanish almost instantly and pose no threat, the speculative possibility has sparked both curiosity and fear. The idea of a black hole being created by high-energy particle collisions has long been the subject of debate. It has added to growing awareness of the dangers associated with such potent experiments. To understand this better, it's crucial to grasp how the LHC could theoretically create a black hole. When protons are accelerated to nearly the speed of light, the energy produced in their collisions is so vast that it distorts the fabric of spacetime itself, like jumping on a trampoline and causing the surface to bend and warp. These distortions raise the unsettling question: could such shifts lead to the formation of a black hole? In the bizarre and perplexing world of quantum physics, where the fundamental laws of the universe often defy logic, there exists a theory suggesting that unknown aspects of our reality may be hidden within the very fabric of space. If such elements exist, the LHC could potentially tap into them, triggering a gravitational anomaly capable of forming a black hole. This possibility has garnered attention from some of the world's most prestigious scientists. The late Stephen Hawking, in particular, warned of the potential dangers of the LHC, especially if the Higgs boson behaves unpredictably at high energy levels. Such an anomaly could trigger a catastrophe known as vacuum degeneration, which might not only annihilate the Earth but unravel the very fabric of the universe itself. Additionally, distinguished cosmologist Sir Martin Rees acknowledged the dangers posed by particle. While the LHC may stand as a monument to our scientific prowess, it is also a gateway, one that opens not only to knowledge but to realms we have yet to fully comprehend. Each experiment brings us closer to uncovering the fundamental truths of our universe, but it also deepens the shadows cast by what we do not yet understand. The pursuit of knowledge is never without consequence. For every discovery made, new questions arise, many of them existential in nature. What is the ultimate purpose of our universe? Is there an end point to our understanding? And perhaps most hauntingly, are we meant to know the answers at all? There is a philosophical weight to what CERN and the LHC represent. It's not just about smashing particles and charting their aftermath, it's about confronting the boundaries of existence itself. When we recreate the conditions of the Big Bang, when we stare into the infancy of everything, we also peer into the unknown future of humanity. This is where science meets something close to spirituality, a recognition that what we are doing is profound, risky, and perhaps even sacred. As the LHC continues its mission, scientists are already envisioning its successor, the Future Circular Collider, FCC, a machine that would dwarf the LHC in scale and energy potential. It promises to reach energy levels 10 times greater, offering new opportunities to discover particles beyond the standard model, explore dark matter, and probe deeper into the mysteries of quantum gravity. But with greater power comes a heightened sense of responsibility. If the LHC raised questions about safety and unintended consequences, the FCC will amplify those concerns exponentially. The same debates will surface again, perhaps louder this time, as humanity edges ever closer to unlocking forces that were, until recently, the domain of gods and legends. And so, the story of the Large Hadron Collider is not just one of wires, magnets, and particles, it is a reflection of us. Of our ambitions, our fears, our insatiable curiosity, and our willingness to reach for what lies just beyond the veil. In a world filled with conflict, division, and uncertainty, the LHC reminds us that we are still capable of unity in pursuit of something greater. That, despite our differences, we can come together to seek answers to the most profound questions of existence. It is both a beacon and a warning, a marvel and a mirror. An exceptional illustration of our desire to comprehend the vastness of the universe, the project speaks volumes about the aims behind it. Over 10,000 technicians, engineers, and scientists from all over the world collaborate with CERN to ensure the machine's success. The scale of the LHC's data collection is staggering, with experiments generating petabytes of data yearly. The processing power needed to handle this colossal quantity of information demands cutting-edge technology that has revolutionized fields like computer science and data science. The results from the LHC experiments go far beyond particle physics, extending into areas like material science and even medicine. For instance, studies in environmental science and the study of heights could have wide-ranging consequences that stretch beyond our comprehension of the universe. One particle, a fundamental part of the standard model of particle physics, plays a crucial role in distributing mass to other particles. Without the Higgs field, the universe would be vastly different, filled with scattered particles in an empty, massless state. Beyond basic understanding, scientists are eager to comprehend the particle's behavior under extreme conditions. These studies could lead to insights that impact everything, from the creation of brand new materials to comprehending the fundamental factors that shape the universe. Another critical aspect of the LHC is its exploration of dark matter. Dark matter is an invisible substance that makes up about 27% of the universe's mass-energy content. Despite its enormous influence, scientists have not yet detected it directly. Dark matter is a major focus of the LHC's experiments, aiming to reveal the potential particles that may constitute it by observing the behavior of particles created during high-energy collisions. If dark matter is finally identified, it could change the way we perceive the universe, unveiling hidden dimensions of spacetime and transforming the fundamentals of modern physics. Alongside dark matter, the LHC explores other exotic realms such as supersymmetry and the potential existence of extra dimensions. Supersymmetry is a theory proposing a connection between two fundamental particle classes, bosons and fermions. It predicts the existence of superpartners, particles that have not yet been observed. If found, supersymmetry could open the door to a new understanding of the fundamental forces of nature, offering deeper insight into the interactions that govern our world. Additionally, the LHC plays a role in advancing quantum computing. By studying subatomic particle behavior, scientists gain insights that could revolutionize the way we process information. Quantum computers, based on the principles of quantum mechanics, have the potential to solve problems currently beyond the reach of classical computers. Technologies developed specifically for the LHC, such as specialized detectors and advanced computing algorithms, have already influenced the field of quantum computing, paving the way for future breakthroughs. Despite its undeniable benefits, the LHC's work also raises fundamental questions about humanity's future. The search for the unknown can be exhilarating, but it also brings the responsibility of considering possible unintended consequences. The same technology that drives the LHC could potentially be used for harmful purposes, such as the development of advanced weapons or scenarios beyond our control. Ethical debates surrounding the LHC are not limited to risks of catastrophic events like black holes or vacuum decay, they also include the potential applications of the research. How do we ensure this information is used responsibly, and that the pursuit of discovery does not inadvertently lead to harm? As we explore the significance of venturing into the unknown, ongoing conversations about balancing scientific progress with ethical responsibility are crucial. The global nature of the LHC's work demands cooperation among multiple countries, each with its own values, priorities, and concerns. Transparency in research, accountability, and international collaboration will be essential to ensure that the knowledge gained benefits humanity as a whole, rather than causing unforeseen harm. The work of CERN through the LHC serves as a reminder that scientific success must always be balanced with a careful examination of its broader consequences. An additional concern is the potential for unanticipated ecological impacts. While the LHC is a relatively contained environment, the enormous energy required to operate such machines raises environmental concerns. Particle accelerators, especially those needing vast quantities of electricity and producing heat, could strain natural ecosystems and resources. Although efforts are being made to use renewable energy sources and enhance efficiency, the broader issue of sustainable scientific exploration must be addressed. Ultimately, the path forward requires a delicate balance. The LHC represents humanity's drive for knowledge, exploration, and discovery. However, with every scientific breakthrough comes the need for ethical reflection and responsibility. The risks involved cannot be overlooked, but the potential benefits could reshape our understanding of the universe in ways we can only begin to imagine. As we journey into the unknown, the focus must remain on ensuring that scientific progress is pursued in a secure, responsible, and beneficial manner, for the sake of future generations. The Large Hadron Collider is much more than just a tool for scientific discovery. It is a symbol of humanity's quest for knowledge and the endless curiosity it inspires about the nature of existence. The LHC's work has raised profound concerns, existential and moral in nature. However, it also demonstrates that through global cooperation and careful oversight, humanity can unlock secrets with the potential to change the course of history. Moreover, the LHC exemplifies how curiosity-driven science can inspire future generations. Its existence fuels education, motivating young minds to pursue careers in physics, engineering, and computer science. The ripple effect of such a monumental scientific project extends into classrooms, universities, and research centers across the globe, encouraging a deeper appreciation for the mysteries of the universe. Public engagement and scientific literacy are also key components of the LHC's mission. By demystifying complex topics and making science accessible to non-specialists, CERN fosters a more informed and engaged society. This is particularly crucial in an era where misinformation can spread rapidly. The LHC's transparency and commitment to education serve as a model for how major scientific institutions can connect with the global public. In addition, the collaborative model of the LHC sets a precedent for tackling other global challenges. Whether it be climate change, pandemics, or energy sustainability, the spirit of international cooperation demonstrated by CERN proves that when humanity comes together for a shared purpose, remarkable progress can be achieved. Looking ahead, the upgrades to the LHC, including the high-luminosity LHC, promise even more powerful experiments, capable of unlocking answers to some of the most profound questions in science. What is the nature of time? Are there parallel universes? Could there be forces or particles we have yet to imagine? Each advance in technology brings us a step closer to these answers, but it also demands a stronger commitment to reflection, dialogue, and accountability. As we push the boundaries of what is known, it is essential to remember that the pursuit of knowledge is not an end in itself. It is a means to enrich human life, to foster peace and cooperation, and to better understand our place in the cosmos. The LHC stands not only as a technological marvel but as a symbol of what can be accomplished when science, ethics, and imagination are united. In essence, the story of the LHC is not just one of particles and accelerators, it is a human story. A story of curiosity, ambition, and the timeless quest to uncover the truths hidden in the fabric of reality. As we continue this journey, we must do so with humility, wisdom, and an unwavering commitment to using our discoveries for the greater good of all.